Looking at this next example, it says it is known that vector m, 2, 1, 0, vector x, negative 1, 0, 2, and y, 1, 1, 3, determine perpendicular distance from vector m to x and y. It's a little bit different, perpendicular distance. So to start off, first thing I will do is I denote two vectors, which will be vector xm in this case and vector xy. Find what these two vectors are. So xm we have equals to vector m minus vector x, and we'll denote that as lowercase m in this case. So m minus x, m in this case is 2, 1, 0, 0, 1, minus x, which is negative 1, 0, and 2. This gives me 2 minus 1 is 2 plus 1, which is 3. 1 minus 0 is 0. 0 minus 2, negative 2. So this is what lowercase m gives me. Now we do what? Xy, vector xy. Xy equals to vector y minus vector x. Y is 1, 1, 3. 1, 1, 3. Minus x, which is negative 1, 0, 2 in this case. Oh, sorry, this is not 0, this is going to be 1, my bad. 3, 1, negative 2. Because 1 minus 0, yeah, 1 minus 0 is just 1, yeah, sorry. So 3, 1, negative 2 is this. Coming back to this, 1 minus 1 is 1 plus 1, which will be 2. 1 minus 0 is 1 minus 0 is 1, and 3 minus 2 is 1. So this is what we get. We'll denote this as lowercase y. Next step is what we're trying to find, which is vector projection of y onto vector m. Vector projection of y onto vector m. We rewrite this. So to solve this, we can find, this will be m dot y all upon magnitude of y squared multiplied by vector y. Next step, m dot y gives me, in this case, dot product. We just take the dot product of vector m and vector y. So 3 times 2 is 6, minus 1 times 1 is 1. 6 minus 1 is 5, multiplied by negative 2 times 1 is negative 2. Sorry, yeah, so 5 minus 2 is 3, all upon oh no, is there a mistake? 3 times 2 is 6, plus, sorry, no, not 3. 3 times 2 is 6, plus 1 times 1 is 1. 7 minus 2, it will be 5. 5. Take the magnitude of y, all squared. Gives me 2 squared is 4, plus 1 will be 5, plus 1, 6. So root 6 multiplied root 6 is 6. So vector projection of y onto m will then be, y onto m is then 5 upon 6, this over here. We'll go 2i plus j plus k in this case. Next, let's denote constant f b. So f lies on the xy. F lies on xy in this case, and is nearest to vector m. correct? Let's know f lies on xy and is nearest to vector m. So what we are going to find then is vector mf, which is going to be projection of y onto m minus m vectors. This is what we're trying to find. mf, vector mf. Coming over here. mf, so is what this is going to be. So let's try and solve this. We know what this already is, which is over here. So 5 on 6. I'll write this as component form. 211 minus m in this case, which is this. We have 3, 1, negative 2. Correct. Further solve this, we get 5 times 2 is 10 upon 6 I plus 5 upon 6 j plus 5 upon 6 k minus 3 I minus 1 or minus j plus 2k. Next step, multiply this by top and bottom by 6. We then get 10 minus 3 times 6 is 18. We get 10i plus 5j plus 5k minus 6 times 3 is 18i minus 6j plus 12k all upon 6. 10 minus 18, negative 6 upon 6 is just negative I. 5 minus 6 is negative 1 minus 1 upon 6 j, and then 5 plus 12 is 17 plus 17 upon 6 k. So that is what vector mf is. Finding the distance, so this is perpendicular, so finding the perpendicular distance. When we find distance, we just use we just take the magnitude of this, so magnitude of mf then gives me 10 minus, that would be 18 upon 6, negative 8 upon 6, sorry, upon 6. Sorry, it's not going to be, yeah, negative 8 upon 6, my bad. Just making a lot of mistakes today, sorry. Yeah, so negative 18, 10 minus 18 is negative 8. Negative 8 upon 6, 5, yep, negative 1, and then 5, yeah, perfect. Next step, calculate the magnitude of this. So I put on your calculator, we have square root of 8 upon 6 all squared plus 1 upon 6 all squared plus 17 upon 6 all squared. This gives me 3.135. Let's go units. So that is the perpendicular distance we get right here. So this is example 2. Now we'll go on to example 3, which will be an exam style question.